Welcome. We're going to talk about linear functions today. The first topic is slope, and we usually denote that with the letter m, and that's just how fast the y-coordinate is changing on the line with respect to the x-coordinate. Change is usually indicated by the capital Greek letter delta, so the slope is delta y over delta x, and what is changed by the difference, so that's y2 minus y1 over x2 minus x1. Let's take a look at an example. On the red line, we can pick any 2 points to compute the slope. Here's point 1, and that's an x-coordinate 1, y-coordinate 4. And here's another point. We'll call it point 2, x-coordinate 3, y-coordinate 0. And so the slope of this line is going to be the change in x over the change in y. Let's put point 1 over here, x-coordinate, y-coordinate, and point 2 has x-coordinate 3, y-coordinate 4, and we just need to take the difference, and when we compute this, we end up with negative 4 over 2, and that simplifies to negative 2. So this line, the red line, has slope negative 2, and it's interesting, it's right there in this form of the line, you can read off the slope directly. And if we make a table for those 2 points that we looked at, the x-coordinate was increasing. It's good to put the points with increasing x values, but the y value was decreasing. So this is called a decreasing function. And if the slope is less than 0, that's when we have a decreasing function. As the x-coordinate increases, the y-coordinate will decrease. But if the slope is positive, we'll have an increasing function. Now, there's still horizontal and vertical lines. If m equals 0, that's when you have a horizontal line. And for a vertical line, well, there are some lines that don't have a slope, and if the slope is not defined, then it's a vertical line. Let's just take a look at an example. We'll erase this, and I'll draw a vertical line. Let's put it over here. So here's a vertical line, and I'm going to pick 2 points on it, any 2 points. Here's one, P1 has coordinates 4, 6, and here's another one, P2, with coordinates 4, 1. And if I compute the slope of that, the slope is going to be the difference quotient. Point 1 will go here, x-coordinate over there, y-coordinate up on the top. And the point 2 is 4, 1, x-coordinate on the bottom, y-coordinate on the top. And we end up with negative 5 divided by 0. But you know, if you divide by 0, the expression is just not defined. There is no value. Although some people say that a vertical line is so steep that we have an infinite slope, or maybe a negative infinite slope. But infinity is not quite a regular number. It's not a real number. So that's just a nice way to think about it. Okay, now let's look at one more topic, and that's parallel and perpendicular lines. Now, parallel lines have the same slope. And if you look at this example, you can see in this example that these 2 lines are perpendicular. They're at a 90 degree angle. And let's see what happens with the slope. What we could do is put a point right here and compute the change in x and y up to here. Here's the change in y, here's the change in x. And the slope here, let's call the slope 2, that's this change in y over this change in x. But if we rotate that 90 degrees, you can see that we're going to have the same picture over here, that the change in x becomes change in y, and the change in y becomes change in x. And so here, this slope will have a negative delta x and a positive delta y. We end up getting this equation that m2 is just the negative reciprocal of m1. And another way to see that, another way to express it is if you multiply the two slopes together, you -1, and that indicates perpendicular lines. So that's the beginning. Let's take a look at more about linear functions. The intercepts. The intercepts are where the line crosses the x and the y axes, and there's the x-intercept. That would be right over here, and this is the point 3, 0, and notice that the y-coordinate is 0, and for the y-intercept, notice that the x is going to equal 0. Here's an example. Here's the y-intercept of the red line. The point is 0, 6, and so we'd say that this line has y-intercept 6 and x-intercept 3. And notice that I'm just giving one number. The point where the line intersects the axes are 3, 0 and 0, 6, but the x and the y-intercepts are just 3 and 6. No big deal if you confuse those two, but the standard is that the y-intercept is just a number, not a point. And let's go to the slope-intercept form. This line here is given in slope-intercept form. We saw before that the slope is -2, and that's right in the equation. But now you would see that that 6 there is actually the y-intercept, and that's usually called b, and that's 6. And the general form is y equals mx plus b, where m is the slope and b is the y-intercept. It's a number, not a point. You're probably familiar with the slope-intercept form, but more useful is the point-slope form, and the point is usually written as x1, y1, and the slope is still written as m, and the equation is y minus y1 equals m times x minus x1. So for example, let's take this point on the red line. The coordinates are 1, 4, and so we could write the equation of the red line in terms of x and y, in terms of the point and the slope. It's so y minus y1 is 4. We know that the slope is -2, and the x-coordinate is x minus 1. And so this equation, that's another equation line, and they're the same line, but different equations. The one on the left is the point-slope form. There's also a standard form. The standard form has the form ax plus by equals c, and this is in standard form for the blue line. It's actually quite easy to figure out both the x-coordinates and the y-coordinates if you have the standard form. So, for example, the x-intercept, notice that y is 0, so we'd have -x plus 2 times 0 equals 2, or -x equals 2, so x equals -2. That's the intercept, and there it is. And the y-intercept has x equals 0, so we put in -0 plus 2y equals 2, and when we solve for y, we see y is 1, and sure enough, that is the y-intercept right up there. So the standard form is very good for computing the x and the y-intercepts, and there's actually one more form which is very similar to that standard form, but it's x over a plus y over b equals 1. That's a variation. And then the x-intercept is a, and the y-intercept is b. So if you actually know the intercepts, you could use that form of the standard form to find an equation for the line immediately. Great, let's solve some problems. So first, let's determine whether the function is increasing or decreasing. And we can write this as y equals 8 minus 3x, and we have to find the slope. This looks a lot like the y equals mx plus b form. That's the slope-intercept form. So we can just rearrange the terms. If we rearrange this, this becomes y equals negative 3x plus 8, and here's the slope. M is 3, slope is 3, that's negative. So that means it's a decreasing function. So the key was just to find the slope, and we used that form of the line to make that easy. Let's take another look at another problem. So here we go. Find the slope of the line that passes through these 2 points. Well, we can use the slope formula. M is y2 minus y1 over x2 minus x1. Let's label this first one as x1, y1, and the second one as x2, y2. It doesn't matter which one we do, we'll get the same answer. So we'll put a 6 and a 4, and that's the second point, and the first point is negative 2 and 8, and we have to subtract them. So it makes sense to put parentheses around the negative 2. And when we simplify it, we get 8 over negative 4, and that becomes negative 2, giving us the slope. Next problem. Find a linear equation satisfying the given conditions, and what we're seeing here is an in-out chart, the x-coordinates and the y-coordinates. So the first one, x is negative 5, that's the input, and the output is negative 4. The second one, the input is 5 and the output is 2. And so we actually have an xy table, and so the slope here is going to be y2 minus y1 over x2 minus x1. Let's say that this is 0.1 and 0.2. That means we have 2 minus negative 4 divided by 5 minus negative 5, and that equals 6 over 10, and that's the slope. But we need a linear equation, and so we have the slope, and we could go and find the intercept, but that's actually extra work. But we'd save time by using the point slope form, because we actually have a point already. We have two points that we could use. So let's just take this one. We could use either one, and we want y minus y1 equals m times x minus x1, and that becomes y minus negative 4 equals 6/10 times x minus negative 5. And that is a linear equation satisfying the given conditions. And if you want to, you could simplify it. Find the intercepts. Okay, we want the x and y intercepts. So let's make a chart, and remember that the x-intercept is where y is 0, and the y-intercept is where x is 0. So we just have to fill out this chart. If y is 0, we have to solve negative 2x plus 5 times 0 equals 40, and 5 times 0 is 0, and this just means x is negative 20. So negative 20 is the x-intercept, and for the y-intercept, we want x to equal 0, so negative 2 times 0 plus 5y equals 40, and that part disappears, so we have y equals 8. That is the y-intercept. This standard form equation makes it so easy to find the x and the y-intercepts. Given the intercepts, find the line. So the x-intercept is at negative 2. This says that b is negative 2, and the y-intercept is at 0, negative 3. That means that a is negative 3. And notice that normally we would say that the x-intercept is negative 2, but you could also say negative 2 comma 0, and same with the y-intercept. So we can use this variant of the standard form to find an equation directly, and this becomes x over, oops, I have those switched. The x-intercept is a, the y-intercept is b, so a is negative 2 and b is negative 3. So x over negative 2 plus y over negative 3 equals 1. That is a linear equation that satisfies both those conditions. And if you want, you could simplify this. You could put it into any other form of a line, or you could leave it like this. Find the value of y if the linear function goes through the following points as has the following slope. So we have 2 points, and we have the slope, and that reminds me of this equation, m equals y2 minus y1 over x2 minus x1. This could be x1, y1, and x2, y2, and m. And so filling that in, we have negative 5 equals the ratio 10 and y is 0.1, and 25 and 100 is 0.2. So we just have to solve this equation. Let's simplify it first. Negative 5 is 100 minus y over 15. And we can multiply both sides by 15 to get negative 75 is 100 minus y. And solving for y, we could let's see, subtract 100 from both sides. Negative 175 equals negative y. And so the final answer, y is 175, gives us the correct value of y. Parallel and perpendicular. Are these lines parallel, perpendicular, or neither? And what we're looking for, let's say that the slope is m1 and the slope here is m2. Parallel would mean that m1 equals m2. Perpendicular means that m1 times m2 is negative 1, or another way to write that is m1 is the negative reciprocal of m2. So let's just check. We can read this off. This is in slope-intercept form. So m1 is 2/3. We can just read that off right there. And we have to do a little bit of work to find the slope of m2, and we could just put it into slope-intercept form. So let's say 2y equals negative 3x plus 1, and y equals negative 3/2 x plus 1/2. And so we can read off now that m2 is negative 3/2. And so I found the slope of both of the lines, and it looks like we're going to be in this situation. m1 times m2 is 2/3 times negative 3/2, and that's negative 1. So these two lines are perpendicular, not parallel and not neither. Okay, let's go to the next problem. Perpendicular through a point. Write an equation for a line perpendicular to this equation and passing through the point negative 4, negative 1. Notice that the variable is not x, it's t, but that doesn't make a difference. What we're really looking at is a slope-intercept form, and so you can see that m, the slope for this is m equals negative 2, and we want a line perpendicular to this, So we want um, the new slope should be the negative reciprocal. Let's say m2, if we call this one m1, is the negative reciprocal, which is negative 1 over negative 2, which is 1/2. So I want a line with a slope 1/2, and it passes through the point negative 4, negative 1. So I'm given a point, and I found the slope. So I should use the point slope form. That'll be the most convenient and the least amount of work. Y minus y1 is m times x minus x1. So it's y minus negative 1, that's the y coordinate, equals 1/2 times x minus x1, that's a negative 4. And I'm almost done, but notice that the problem was given with a variable t, and not in y form, but as a function. So I can change this to f of t minus negative 1 equals 1/2 t minus negative 4. And we're actually good to go. This is an equation, but since the original equation was given in point slope form, we could probably solve for f of t, and that's going to be, looks like 1/2 t. That gives this part. We're going to have a 1/2 times negative 4, which is 4. We're going to add negative 1 to both sides. So it'll be minus 1. That's 2 minus 1, which is 1. So this will simplify to 1/2 of t plus 1. That will have a perpendicular slope, and will go through the point negative 4, negative 1. And if we're not sure, we could check that out. But let's see what we have. We're actually at the end of the problems. So I'm going to stop here and wish you a great day.